Today we're going to be talking about how to find the volume of various prisms. So you should have just gotten done doing the naming 3D shapes. So we're going to do the same thing right here. We're just going to really briefly talk about it. Remember, prisms are 3D solids with identical, parallel bases. So all that is saying is that the top and the bottom of our shape are exactly the same, or they could be twisted on their side and they're exactly the same on one side or the other. So identical, parallel bases. So basically the way you kind of think about it is any way that you make a three-dimensional shape. So you start with this rectangle right here, and I want to make it 3D. So I extend all of these lines backwards. So basically I'm grabbing this rectangle and I'm stretching it back this way. Then when I connect all of these lines together, if we were to peer through the shape, that first rectangle, the one in front, is still there. I just stretched it backwards. The same is true with a triangular prism. I start with any regular old triangle like this, and then if I stretch it back this way, I end up with that same triangle all the way at the other end. All right, so in these boxes we're going to put our formula to find the volume of a rectangular prism. It is length times width times height. Now this height here, the big H, is the distance between the bases. So on this rectangular prism right here, depending on which rectangle we call the base. So if I say it's this front rectangle right here, the other base is this back rectangle. They're exactly the same, they're identical, and they're parallel. Then height, my big height, is that right there, that distance from one highlighted rectangle to the other highlighted rectangle. In a triangular prism, part of its formula has the big height, but it looks like this. Base times little height times big height divided by 2. So down here on this triangle, what we have to do to find the volume of any one of our prisms here, we first have to find area. So in this case, this triangle right here has area. Well, if we think back to what we did last week on block day, how do we find the area of a triangle? We find it by base times height divided by 2. So this part of our formula, I'm going to circle it, is just the area of a triangle. Why do we have to do the area of the triangle? Because we have a triangle. Then this H, big H, is that distance from one triangle to the next triangle right here. So that triangle, so big height. I'm going to switch colors. Let me grab red here. So if I have my triangle, there's my right angle symbol. So that right there is little height. That makes this dotted line in the back the base, because remember, this right angle always connects our base and our height. So there's little b, there's little h, connected to the big H. So it's as if I took the triangles from last week that were 2D, they're just sitting flat, piece of paper, and I grabbed them and I pulled them off the paper and elongated them. The next one, trapezoidal prisms. They're called trapezoidal prisms because we've got a nice trapezoid on one side. And we have a nice trapezoid on the other. To find the volume of one of these, we have to do base 1 plus base 2 times little height times big height divided by 2. And again, I hope the first thing that you notice is that the first part of this formula is just the area that we did the other week. Not just any area of a trapezoid. So where does that big H fit in? It's the distance between your trapezoids. So in this case, from the bottom to the top. This height, bottom to the top. Now the way that I highlighted this one, the height was, going from the front to the back, but the base of this rectangular prism could be the bottom. So if I were to go through and label all the pieces, I have length, I have width, I have height, I have base, little height, big height. I end up with this one, base 1, base 2, which is the same as this side right there as well. It's just a little hard to write it. And then need my height for my trapezoid right there, big height. That's all it is. I didn't circle it, but I want to go back. Length times width, that's just another way to find the area of a rectangle. So how do we find the volume of any prism? So I've got a bunch of prisms right here. We don't have the area formulas for a pentagon. We don't have the area formulas for a hexagon. We don't have the area formula for an octagon. But that does not matter, because all we need to do is find the area of that. Well, I know we just said you don't have the formula, but we're going to find the area of the base, either one of these hexagons, and then we're going to multiply by how tall the prism is. So from that octagon to this octagon, so area formula for any prism, big B times big H. Big B is the area of the base. So in all of these formulas, we had area, area, area. So big B, area of the base. Height, the height of the prism. Whoops. From one end to the other. So we're going to go through, we're going to practice this on every single one of these shapes. That way we have one to draw from in case we get a little bit stuck. So this side right here is going to be 6, this side's going to be 8, and this side's going to be 10. Now a rectangular prism is our all-time favorite. This is the one that we always want to see. It's length times width times height. And because there's no addition or subtraction or anything right here, any one of these numbers could be the length. Any one of these numbers could be the height. Any one of these could be the width. So if I were to say this is 8 times 10 times 6 in that order, what I just did in my picture is I called this bottom rectangle the base, which makes sense because we like base to be the bottom. Doesn't always have to be, but it can be. So how do I find the area of that highlighted rectangle? Well, we take 8 times 10. Now, how far is one rectangle from the other? It's 6. All we have to do is multiply that. I'm going to grab my calculator. I have it right here. 6 times 8 times 10. And we get 480 units cubed for volume. Since we have 3 numbers, we're going to cube it. 1, 2, 3, and we're multiplying them. So just like if you were to multiply 3 times 3 times 3, we get cubed. The other reason is volume is calculated by taking little tiny cubes and filling in this 3D shape. Let's jump down to our next one. It is a trapezoidal prism. So to find the volume of a trapezoidal prism, we're going to have to take base 1 plus base 2 times the little height times the big height and divide it all by 2 in the end. All right. Feels like a lot, but we just got to keep track of all of our numbers and make sure we put them in the right spot. So jumping over here, trapezoidal prism, all we care about is the trapezoid itself. There it is. So the trapezoid itself, this side is 5, this side is 10, and this distance right there is 4. So those 3 numbers right there are only about the trapezoid. So far in our formula, we have 5 plus 10 times 4. So that's what we have. What we don't have yet is our height. That distance from one trapezoid all the way to the other side of our prism, all the way up here. That number I'm going to put in pink. Actually, I've already used pink. It's going to stand out. Let's use orange. And that number's right here, and we're going to make it a 12. So it's even easier for you guys to kind of see where that 12 fits into the formula. Then we just have to remember to divide it all by 2. So what I do on my calculator, we could type that whole thing in right there. But if we type that whole thing in, we are going to have to use parentheses at the right time. So I would have to type in 5 plus 10 in parentheses times 4 times 12 divided by 2. And we get 360. What I like to do instead is kind of go piece by piece. So I start 5 plus 10. Then I multiply the 4. Then I multiply the 12. And then I divide by 2. One step at a time, we get the same answer. Volume equals 360 units cubed worth of volume. All right, let's flip it over to the second page. Got a few more of our shapes. Top one right here, that is a triangular prism. So a triangular prism. We need to find the volume by taking base times height times big height, dividing by 2. So I'm going to just start by filling in the information we get from just the triangle. Okay, so this number right here is going to be 12. Here's that right angle symbol right there. This number is going to be 6. While this number over here is going to be 15. So when I plug this in, I get 12 times 6 times 15, all divided by 2. All right. So, doing it one stop at a time, what I like to do is everything on the top. So I do 12 times 6 times 15, and then I divide by 2. So our answer ends up being 540 units cubed. The next one, rectangular prism, just to show you. What if I said this rectangle over here was our base? So that means its identical buddy is way over here on this side. Maybe I tipped the rectangular prism over on its side. And this front side right here is 10, this side right here is 5, and this right here is 7. Volume equals length times width times height. So I have 10 times 5 times 7. 10 times 5 is 50. 50 times 7 is 350 units cubed worth of volume. Next one, another triangular prism. We know it's a triangular prism. We got those opposite identical triangles. This number is going to be 8. This number is going to be 12. This number is going to be 13. So just like finding area, our right angle symbol is very, very important. So this right angle symbol right here is still telling us that's your height, that's your base, which leaves 13 as our big height. So I've got, oops, let's put this in the right order, 8 times 12 times 13, all divided by 2. I'm not 100% sure what this one is, so I'm going to grab my calculator and I do 8 times 12 times 13 divided by 2. And we get 624 units cubed worth of volume. Next one, we have a trapezoidal prism. It's been tipped over on its side, so it's not standing straight up like the other one. First job is to find that trapezoid right there. The other one's way back in the distance over here. All right, let's start by labeling all the stuff that we have in just our trapezoid. So this bottom length is going to be 14. This top length is going to be 10. So in our formula of base 1 plus base 2, remember always in parentheses, times the little height times the big height divided by 2, we just got 14 and 10 as our bases. The next piece we need is our little height. That's found on this line right here. It's going to be a 6. We need our big height. That's the distance from one trapezoid all the way back to this one. And that distance is going to be 20. This is the only one where we got to be very careful. We have to do that parentheses before we do anything else. So 14 plus 10. So I'm going to do that, get 24. Multiply the 6, multiply the 20, divide the 2, and we get 1440 units cubed worth of volume. All right, our last two on this page are two special prisms. One is a pentagonal prism. That's this first one right here. And this one is a hexagonal prism. We do not have a direct area formula for a pentagon or a hexagon. Now you guys are wicked smart. I know you guys are looking at it, you might be like, well, Carla, we could draw a line straight across this pentagon and we'd have a triangle and a trapezoid. We find the area of each, we add them together just like what we did on block day. Then once I have that area, I can multiply by the height of our prism. You are correct. We could do that. I know you can do that. But remember, the volume formula for any prism is the area of the base times the height. So if I told you that this pentagon right here has an area of 120 feet squared, you don't have to go and find the area because I already told you what it is. You can put the 120 right there. All you would need to figure out is the height of our prism. And for this one, we're going to say that it's 7 feet. So we take the area, we multiply the height. We should get, I think it's 840, but I want to just make sure that my math is correct tonight. And that is 840 feet cubed worth of volume. So if you were faced with a problem where you didn't know the area, yes, you would cut this right there and make a triangle, make a trapezoid. Hopefully you have the information to find the area from there. But that is not what we need to worry about right now. Maybe that'll be some level 4 questions later on. But we're just trying to get the hang of our volume formulas. So area of the base times the height. So the area of this hexagon is going to be 200 centimeters squared of area. So if you already know the area, you could just plug it in for B. It's 200. The height from one hexagon on the top to the bottom hexagon down there, we're going to say it's 15 centimeters. I don't know, I'm just making up the number, so why not? 200 times 15, I'm pretty sure, is 3,000 centimeters cubed worth of volume. And that is how you find the area of any one of our prisms. Remember that it's the distance from one base to the other that makes our big height. So I'm just going to go back through. I'm going to highlight in the other two bases just so we have some continuity. All right. That's volume of prisms.